Okay, this is 11.2, way delayed, but let's talk about techniques of evaluating limits. So we have basically 5 strategies here. Number 1 is direct substitution. Just take the value that the limit's going towards, that C, and plug it in. And if it works, then you know that's where you're going to. But then if it doesn't work, then you have to do a couple different options here. You can divide out technique. So in other words, cancel the common factors and simplify, then do direct substitution. The other one is rationalize, multiply the numerator and denominator by a conjugate, then do direct substitution. In other words, how can we simplify the function so that when we do put in the value, that C value of our limit, that it actually works, okay? And this, unfortunately, is where a lot of you are having trouble. So simplify a complex fraction, multiply numerator and denominator by the lowest common denominator, and then use direct substitution, and then lastly, use trig identities. So what does this mean? This means that if we came up here and we used direct substitution, so we came in here and we said, okay, well, let's just go f of 2, and we put that in here. We go 2 minus 2, and this would be 2 cubed minus 2 times 2 squared plus 2 times 2. So we use direct substitution. Everywhere where there's an x, we substituted in 2. When we did that, we got 0 over 0. So it's what's called indeterminate. A lot of people say undefined. So it's undefined at that point, but it doesn't mean that we don't have a limit. It doesn't mean that there isn't a limit as we approach 2. So we have to find out what that limit is. And to do that, we take our function, this function here, and we simplify it. In this case, we factor the bottom, and some of you need to keep working on your factoring. I don't know, my thing's having a lot of trouble here. Plus 2, and then x minus 2. Okay, so that gives me, after simplifying, oh, boy, I'm having a lot of trouble right now. Hopefully we're still recording. I think we are. I'll try to be a little more gentle here. Okay, so we have the limit as x approaches 2, x approaches 2. Okay, we have x minus 2 on top. We have x squared plus 2 on bottom, and x minus 2 on top. So these two, x minus 2, they cancel out. So that leaves us with 1 over x squared plus 2. Boy, this thing's really... So now if we sat there and said, well, let's take the limit as x approaches 2 of 1 over x squared plus 2. In this case, now we do direct substitution. So we could say, f of 2 equals 2 squared plus 2. So that is, what, 1/6. Okay, so as x is approaching 2, then our y, our output, is approaching 1/6. So it does have a limit, okay? It's just we couldn't find it using direct substitution. Hopefully that makes sense. I've got to be really delicate here. It's being really weird. Okay, so same thing again here. I'm just going to, for brevity's sakes, not 0, 2. Direct substitution first, just in case. 2 to the 4th. 2 to the 4th, 6, 2 squared plus 8. Okay, and I'm going to figure that this is going to come out to be 0, 0, and again, it's indeterminate. I don't have my key with me, but I'm pretty certain that's what it winds up being. So now I have to come in here and I say, okay, we'll take the limit as x approaches 2, and we're going to factor these out. This is where it helps if you know how to factor. This is x squared, x squared, x squared, x squared. This is going to be 4 and 2. And this is negative, positive. And this is also going to be 4 and 2. And these are both going to be negative. Okay, so again, helps if you know how to factor. Okay, and then after doing that, these cancel out. That leaves us with the limit as x approaches 2 of x squared plus 2 over x squared minus 2. So now we'll do our direct substitution. We'll say, okay, well, what if we put 2 in here? We would have 2 squared plus 2 over 2 squared minus 2. That would be 4 plus 2, 4 minus 2. That would be 6 over 2. So that answer would be 3. Okay, I didn't do very much here because I'm having trouble with my iPad, so I'm going to stop with that and work on the rest after I figure out what's going on with my iPad.